So there is a new neural network architecture you might be interested in. It is called the Baby Dragon Hatchling. This is BDH. And this new neural network architecture blends the strength of transformers with biology. It's an inspired brain model. And unlike traditional models that rely on global attention, the BDH operates through local interactions between simulated neurons on a scale-free network. What does that mean? Well, that means that it demonstrates how neural networks in human brains might be governed by the same equation of reasoning. And that's what they're using to make this model work. And if true, this actually bridges artificial and biological intelligence in a way that no other model has before, and it suggests that future AI could learn and reason more naturally, basically using less math and more thought. For society, that means that we're edging towards a model that not only performs like humans, but also thinks in a way that we can finally understand. Right now, it's matching GPT-2 level performance while remaining interpretable, more brain-like. Actually, more brain-like doesn't make me necessarily think it's more interpretable, but they argue that it is more interpretable. And interpretability is something so important if we're going to make it through the alignment issue of the singularity safely. We have to know why these models are making the decisions they make so that we know what we can trust and what we can't. Okay, so it's considered interpretable because its internal structure is closer to how a neuron in the brain acts. So each artificial neuron ends up having a defined role, so it's either excitatory or inhibitory. It's kind of like how our brain has like that spike of electricity or nothing. And each one is connected locally in a way that can be traced and visualized. So you can literally see which neurons influence each other and how their activity patterns evolve during reasoning. It's a little bit different than backpropagation, where you're sort of spreading out the error rate and you don't get an exact neuron which goes up or down or fires or doesn't fire. And then on top of that, it does something else that most neural networks don't do, and that's called Hebbian learning. Basically, neurons that fire together wire together, which means the network changes are biologically meaningful and explainable, not just the result of gradient descent or over millions of parameters. It's like a living circuit instead of a black box full of mysterious numbers.